Yes, in the previous class we have learned about this one.
Yes, sir.
Hmm? Uh,
Yes, sir.
so today we shall be discussing the properties of solid, liquid, and gas. Can you tell me the last topic that we have studied? Can you tell me the last topic that we have studied? Well,
Say it was we were discussing about the states of matter, and we have done that till gases.
do we have
We also
done this?
discussed about atmospheric pressure.
Okay. Okay. Just wait a minute. Today we shall be going to discuss the change in states of matter. Okay. Just give me. Change in the states of matter. Okay. As you are very much familiar that if I'm talking about the change in states of matter, okay. So when the states is going to change, okay, when a substance is going to change its state, then uh, there is one thing that is going to happen here, okay, the temperature, okay. I have told you in the previous class that it is the pressure that is responsible for changing the state of matter, and it is temperature that is responsible for changing the states of matter, okay. So if I'm going to convert solid into liquids, okay, solids into liquids, what I need to do is I need to increase the heat. So heat should be increased, okay, and pressure should be decreased. Pressure should be decreased. So we can say pressure should be decreased and heat should be increased. Okay. So by increasing the heat, by increasing the temperature, by increasing the temperature, and by decreasing the pressure, and by decreasing the pressure. Okay. You understood?
Yes, sir.
Okay. So I'm saying here that pressure, you know that when the state is going to change. Okay, for example, this is solid and solids are converting into the liquids. The particles are very much separated and far apart. Okay, like I'm having here. So you can check that these are the particles of solids and you want to make them, okay, move freely in the container. So you know that when we are just moving this one, so the particle can move from here to here. Okay, particle can move from here to, okay. uh and because of that, they can freely move. Okay, so what is this? This is solid, and the solid, the energy is very less. Solid kinetic energy is very less, or we can say no kinetic energy of the particles. Okay, kinetic kinetic energy of particle is very minimum. Kinetic energy is very less. And here you can check that kinetic energy of particles when you heat, okay, heat the substance, then it increases, the temperature increases, and the kinetic energy of increase of the particles increases. Okay. So due to increase in temperature, increase in temperature, we'll simply say that the kinetic energy of the particle increases. Kinetic energy of particle increases. Okay, note it down, please. Note each and everything properly. Make this one. And since you release the pressure, the particle can move. For example, if you are just seated congested,ly okay, and you are just applying the same example, this is the piston, okay, and I'm having here this, I'm applying the pressure here, high pressure here. The particles are very tightly packed here. They are not free to move. So due to increase in pressure, they are not free to move. So if you are applying the pressure, and if you decrease the pressure, let's suppose this piston goes up, then these particles will get more space and they can move freely. Okay, they can move freely. Got it? Got it?
Yes, sir.
So when you decrease the pressure, the particles can move freely. So we can say that in solid, the kinetic energy of particle is very less, and due to increase in temperature, the kinetic energy of particle increases, which result in the movement of particle, and as a result of it, it can change its states. Okay. So, but you need to note one thing here, that when the states, okay, that when the state is being changed, okay, states, I'm talking about the states. Okay, for example, solid is being converted into liquids. I'm saying, for example, solids are converted into liquids. You all know that solid convergence take place at a particular temperature. Like for example, ice is also at 0 degree Celsius. Okay, ice melts and freezes both at 0 degree temperature. Okay, ice melt at 0 degree Celsius, and water freezes at 0 degree Celsius. Okay. So why we can simply say here that if the solids are converted into liquids, then why the temperature does not increase? Let's suppose if you take some ice cube, okay, in this container, okay, you take some ice cube and you add a thermometer here. Okay. So you will notice that the temperature will not rise. And even if you are applying the heat, the temperature does not rise. Why the temperature is not rising? Can you tell me? Tell me. Why the temperature does not rise?
So,
Because, yeah,
so is it because the cohesive bond between the molecules in the solid must be broken apart such that
I will simply say that all the heat is going in overcoming the force of attraction. For example, this is a solid particles. Okay, they are tightly packed together. And you want this solid particle to move freely, like this way. So they are tightly bonded together. They are having force of attraction between them. They attract each other. So if you want to move them freely, then you have to break their force of attraction. So the force of attraction, we need to decrease the force of attraction. And for that, what we need to do is we need to apply heat, and that heat energy is going in overcoming the force of attraction. Okay. So what we can say here, that why do the temperature do not rise? Okay. Why do the temperature do not rise when ice melts to liquid water? Ice melt to liquid water, or any solid changes states, or any solid changes into liquid, changes into liquids. Okay, got it?
Yes, sir.
So if I'm saying that the answer for this question is that the all the force that we are using here, it is going in overcoming the force of attraction between the particles of solids. Okay, so we'll simply say here that where does the temperature, or we can say that where the heat goes, it goes in overcoming the force of attraction, and that is known as latent heat of vaporization. Okay, latent heat of vaporization. So I'm saying here that what is latent heat of vaporization, and sorry, latent heat of fusion. So let's have you noted this question, everybody?
Yes, sir.
So note it down that where does the heat goes? So you have to write that the heat goes, the heat goes in overcoming the force of attraction between the particles of solids, so that so that they can move freely, they can move move freely freely in liquid form or liquid state. Note it down.
Yes, sir.
Okay. Everybody, note. Everybody done?
Yes, sir.
Yes, sir.
Okay. Top. Write down the topic. What is latent heat? Latent heat. The word latent comes. No, just wait a minute. I'm just coming back. Okay. So I'm saying here that what is latent heat? Just concentrate here, dear students. What is latent heat? The word latent heat means hidden. Hidden means hidden. What do you mean by the word hidden? Hidden means that does not appears. Okay. For example, if you are having a means if you are heating a beaker. Okay. If you are heating beaker and and this is water inside it. Okay. And suppose this is solid. This is solid, or you can say ice, or anything that is changing states. Liquid too change their state into gases. Okay. So if the liquids are changing their states, the temperature does not change. The temperature does not change. Okay. So where does the heat goes? Like for example, I'm just showing you here that you can watch it. Like for example, if I'm boiling a water, I can boil a water in a polythene. I can boil a water in a polythene. You know that polythene easily catch fire. Everybody know that polythene easily catch fire. Yes or no? But if I fill the polythene with
Yes,
water, if I fill the polythene with water, then this polythene, actually polythene temperature, the burning temperature of polythene is greater than 100 degree temperature. Okay. So if the water is present in that one, so unless and until the whole water get evaporated, the water will start boiling at 100 degrees Celsius, and unless and until all water from the polythene get evaporated, okay, the polythene will not burn. Okay, let me show you this, that boiling of water in polythene. Just wait a minute. Okay, I'm saying here that the water is boiling in this polythene and he is boiling the egg inside the polythene. Okay. And why he is boiling? Why is boiling? Okay. So simple reason is that because unless and until all the temperature of this one is, means all the water will keep on boiling unless and until the temperature will means all the water get evaporated, and we'll simply say, okay, that this boiling temperature will when the polythene boils at more than 100 degree temperature and the heat is supplied in boiling the temperature, it will not allow it to boil it. Okay, so just watch the video. You are watching this one, dear students, that he is boiling.
Yes, sir.
So where does the heat goes? Where
Yes,
the
sir.
heat is going on? The heat is going all in boiling the temperature of in boiling. The polythene is not boiling because the all the heat is supplied in the water. It is being transferred. It will not allow the water, the temperature of the polythene to rise above 100 degree temperature. Okay. Okay. So heat is going. This is known as latent heat. What is latent heat? Latent heat, we say that the amount of heat that is required to remove the temperature. Oh, sorry. That is required. Let me write it. Just wait. Just a minute. What is latent heat? Note it down. Latent heat of latent heat. First write the definition of latent heat only. Then there are two types of latent heat. Okay, what is latent heat? This is the amount of heat. This is the amount of heat required to convert 1 kg of substance. But don't write it convert. Just wait a minute. Write it. Required to change the state of matter. Required to change the state of matter without rising the temperature. Of matter without rising the temperature. So what I'm saying here is that latent heat are of two types. Latent heat are of two types. Note it down. The first is latent heat of vaporization, yeah, latent heat of fusion first. Latent heat of fusion, and the second one is latent heat of vaporization. Latent heat please note it down. You done? Noted, everybody?
Yes, sir.
Tell me then,
Yes,
what
sir.
is latent heat? Latent, the word latent means hidden. The word latent means hidden. Hidden heat. Why I'm saying this is hidden heat? You can check in the polythene, case of polythene, that we are just boiling the water. It is changing the state. It is changing the gas. Why the polythene is not burning? Because the water present inside it, okay, the heat you are supplying, that is going into in the water, and it is changing its states into gas. And it will not allow to rise the temperature. Okay. Similarly, if the ice is melting, if you are keeping a glass and you are having ice cubes inside it, okay, ice cubes inside it. These are the ice cubes, and the temperature of this ice cube is not rising. The temperature of this ice cube is not rising. Why it is not rising? When we are just heating, why means unless and until all the ice get melted, the temperature will not rise. For example, if you keep the thermometer inside it, okay, and in that thermometer, you will mark that the temperature will remain constant at 0 degree temperature, even though if you are applying the heat over it. Even though, let me show you this experiment also. Just a minute. Why does the temperature do not rise? Just wait a minute. The experiment is not here, I think so. Okay, this experiment is not here. So let me explain you. The where does the heat is going? So, and why the temperature do not rise? So write down a question here, that why does the temperature do not rises when ice is melting? Same question that we have done discussed there. If the ice or anything is melting, okay, that because heat there is going in the form of latent heat of fusion. Okay, so what is latent heat of fusion? Latent heat of fusion. We will say that it is the amount of heat. For example, you take 1 kg of ice, 1 kg of ice, okay, and then you convert it into 1 kg of liquid water. And the terms and condition is that it should be at 0 degree temperature, and should be all the water should be at 0 degree temperature, and temperature should not rise. And still the process is including the heat. Okay, this is including the heat. So here this heat is known as latent heat of vaporization. Sorry, latent heat of fusion. This heat is known as latent heat of fusion. This heat is known as latent heat of fusion. Latent heat of fusion. So what is latent heat of fusion? If I write the definition, it is the amount of heat required to convert 1 kg of solids completely into liquid at its melting point. At its melting point. Melting point is 0 degree. Or without increasing the temperature. You can write it without increasing the temperatures. Everybody understood? You, Arhan, Saad,
Yes,
and
sir.
Samia, you understood?
Yes, sir.
So
Yes,
Yes, sir.
what is latent heat of fusion? What is latent heat of fusion? This is the amount of heat. This is the amount of heat required to convert. Okay, this is the amount of heat required to convert 1 kg of solid completely into liquids. Completely into liquids without increasing the temperature. At its melting point. Melting point. At its melting point. At its. Noted? Noted?
yes,
Okay. So Samia, tell me that what is latent rate of fusion? What is latent rate of fusion? Tell me, Samia. You can read the definition also.
so the amount of heat energy released or absorbed but when a solid changing to liquid at atmospheric pressure at its melting point.
No, no, I have, you wrote the definition recently, na? So read that definition only. Read the definition that I have written previously here. This definition. Read that this definition. You said you have noted, na? So if you have
Yes,
noted, let me know. So please
sir,
read the
I
definition.
marked in the book. Sir, I just marked in the book.
You just mark in the book. Who told you to mark in the book? Who told you to mark in the book? Arhan, you read the definition, please. Arhan,
Yes, sir.
read the definition of latent heat of fusion.
So amount of heat that is required to uh,
Do what? Why are you not writing? Saad, read the definition, please. Saad, are you there? Saad, Saad, are you there? Unmute your mic. Unmute your mic. Write each and everything again. write each and every definition again that I'm teaching you from the beginning. Start writing. Why do temperature do not rise when ice melt to liquids? I will check your notes after the class is going to end. Note it down each and everything in your copy. Note it down. Note this one also. I.e. Turn on your camera, everybody. Turn on your camera. Let me check whether you are writing or not. Samia, Arham, and Saad. Turn on your camera. Arham, Samia, and Saad. Are you listening to me?
Yes,
Turn on your camera.
sir.
You're making fool to your teachers. Let it be. We will check it. We'll check it. Saad, you have to turn on your camera. Everybody is taking the screenshot. Saad, are you turning on the camera or we should talk to your parents? No, I can't see you. Have you noted this one? Up to here? This along with this question. Done?
Yes, sir.
Write it down. Latent heat. This is the amount of heat required to change the state of matter without rising the temperature. and they are of two types. Saad, neither you are just turning on your camera nor your face is visible to me. Done?
Yes, sir.
Noted up to here?
Yes, sir.
You also, Samia? Yes. Okay. So what is latent heat of fusion? Note it down. Latent heat of fusion. What is latent heat? Hidden heat. Okay. So if I'm talking about the fusion, it means that this is the amount of heat required to convert 1 kg of solids completely into liquid without increasing the temperature. I will check you after the class. You have to send your notes. Okay, dear students? You have to send your notes. We will check whether you are maintaining your copy or not. Okay. Is that clear?
Yes, sir.
If you have not done, then this is the first time that I'm going to leave you. You have to complete your copy. We will provide you the assignment again and the classwork that we have done here up to. Okay, but you have to maintain your copy properly. If you keep on skipping, this is laziness. Okay, you are having pen. Your teacher is teaching you. Still, you are not writing the notes. Then when will you write? They will not going to give you the proper timing. Next, have you done this one, Samia and Aram both? And Saad, where are you?
I've done, sir.
Keep turning on your camera. Okay. Next, I'm talking. Next is latent heat of vaporization. Next is latent heat of vaporization. Latent heat. Latent heat of vaporization. It is the amount of heat required. Vaporization means that something is converting into the vapor state. Okay, so it is the amount of heat required to convert 1 kg of liquid into gas without increasing the temperature or at its boiling point. Its boiling point. Note it down.
Absolutely.
Sir, done.
Okay. Similarly, when we are just converting solids, like for example, if you are boiling the water 100 degrees Celsius water, okay, till the whole water get converted, it is liquid water, okay, and water vapor. They both have 100-degree temperature, okay. Water boils at 100-degree temperature. But you will feel here that since the liquid water is converting into water vapor, the temperature do not rises. It will remain constant. Polythene in that experiment that I was showing you, in that experiment, the polythene could have melt but the melting temperature of polythene is greater than 100-degree temperature. And since water present it does not allow to rise the temperature above 100. So that's why the latent heat of due to latent heat of vaporization, temperature does not rises, or due to change in the states of matter, the temperature do not rises. Why? Because when the state is being changed, the temperature remain constant. Why the temperature remain constant? Because it is used in overcoming the force of attraction. For example, solids particles are tightly bonded together. They are tightly bonded together. They are not free to move. And if you need to convert it into liquid, the particle should move freely. So they are tightly bonded together, and they need to the force of attraction between them should be decrease. Okay, so the heat goes in decreasing the force of attraction. And how the force of attraction can be decreased? By making the particle movable. How can the particle be movable? How can the particle become movable? If they are tightly packed, how they can move? When you increase the kinetic energy. So when you increase the kinetic energy, the particle can move freely. So what we does here is that when we are changing the solid into gas or solid into liquids, we are just increasing the particles, kinetic energy of the particles. Okay. So if I ask you that again, the same question, where does the heat goes when we are changing the solids into liquids? Where does the heat goes?
Say it goes to break the force of attraction between the solids.
And second, tell me, Samia. It goes
The force of attraction.
in decreasing the force of attraction and increasing the kinetic energy of the particles. Okay. Increasing the kinetic energy of the particles. Okay. Understood?
That's it.
Yes.
Understood? The temperature does not change. Okay. And here one thing you need to note that a question comes in examination that generally solids, okay, generally we watch that solid, okay, when we are having an iron nail, okay, in iron nail kept in water, it get sink. Okay, why do it get sink? Why do it get sink? Because the density of iron nail is greater than the density of water. So those substances which are higher, which is going to have high mass density, okay, and they are capped in the liquid which is having low mass density, then it will sink. Okay, means the mass or higher density substance gets sink in the lower density liquids. Okay, so note it down. Note it down. Generally, higher density substance solid sink in lower density liquids. Okay, lower density liquids. So if the question comes that you know that solid is, oh sorry, ice is solid and liquid is water is liquid. Okay, so everybody know that when you kept the ice cube in water, it floats on the surface of it. Can you tell me why do, if the question comes in examination, that why do ice float on the surface of water?
So because it has lower density than the water.
Okay, very good, very good. So why do it has low density? What make it low density? So let me show you that. First, let me explain you that what is density. Density is the particular amount of substance. Okay, what is density? Particular amount of substance or particular mass kept in per liter of space. Okay. For example, if I'm having, let's suppose if I'm having this cube, it is having dimension of 1 centimeter length, 1 centimeter breadth, and 1 centimeter height. Okay. So its volume will be L into B into H. That would be 1 centimeter cube. Its spaces. If I have the same size iron, same size gold, same size lithium. Okay, so we will find that the gold will be heavier in all of them. Lithium will be the lightest. Lithium will be having only 0.5 gram. Gold is going to have more than 18 grams. Okay, the same. This is only 0.5 grams, not even 1 gram mass is there in lithium, if it is lithium. So we'll say that the same space is occupied by lithium also, same space is occupied by gold also, the same space is occupied by iron. But the heavier one will be the gold and the lighter one will be of lithium. So lithium, if we make the same cube with lithium, it will be very light in weight. If we make the same cube with gold, it will be heaviest in all this. Okay. So why? Because gold particles are heavier and they carry more mass. The same thing is that if I kept, okay, for example, if I got water, normal water particles. Okay, I'm having normal water particles, and these water particles, when they condense, when they freeze, now they are having random motion. One here, they are moving here and there. They are just moving from one place to another place. This is the water molecules, and they are moving from one place to another place, like in a random motion. Okay, like in the random motion. They are moving here and there. But when water get freeze. When water get freeze, then they have a specialized structure. They have a specialized structure like this.
It's a crystal structure.
Yeah. Okay, this is like this. And this space here, there is no substance present. So this space occupy air inside it. Okay, means the water particles arrange in a particular pattern, and they are having air inside it, inside their space. Okay, so due to that, the density decreases. We'll simply say that water is a liquid which is having more density in liquid state than it's in solid state. Generally, solids are more denser than liquids. Generally, solids are more denser than liquids. They have high densities. But in case of water and some other substance also, okay, in case of water, we'll simply say that when the water is at 4 degrees Celsius, it has highest density. Highest density. Water at 4 degrees Celsius. Water at 4 degrees Celsius has highest density. Okay. And it get converted into ice. It has lower density. Lower density. And I have told you that the substance that is going to have low density, the substance that is going to have low density that float on the surface of the water. Okay. Okay. So let me show you that how can you prove that when water is in the liquid solid state, it has okay more density, sorry, less density. So how can you explain? Let me explain. The density's formula is, just concentrate, Aram, turn on your camera, beta, turn on your camera. Density is equals to mass upon volume. You know, density is equals to mass upon volume. Okay. Now you know that, okay, this is density. Density is equal to mass upon volume. And density, now I'm saying that the mass, if the state is changing, okay. If I'm saying that the mass will remain same, if you kept, suppose you are having a bottle and you are having water inside it. Whether you are having water in the liquid state or in the solid state, mass will not change. Weight. For example, if you are having a bottle filled with water, even if you change it into solid or liquid, because the matter is not increasing now, you are not adding more water. How the mass will increase or decrease? When you are removing the water from the bottle or you are adding the water to the bottle. For example, this is a bottle. Okay, if I drink some water from it, okay, then the mass of the particle, because I have drink some water particle from it, so that's why the mass of this substance decreases. Okay, decreases. But if I'm saying that I'm not going to evolve, or we can say I'm not going to remove in a single drop of it, I've just kept it up to brim and I've just kept it in with tight. Okay, I'm just keeping it like tightly and I just kept it into the refrigerator. So mass is fixed. But I'm saying that the density is going to decrease. Density. So what is going to have? To increase the density, to decrease the density. For example, if I'm saying that 5.2, I'm writing here 5.2, something. Okay. And this will be 2.5. If I want to decrease this value more, so what I will write? I will decrease, and I'm saying that you are not going to change this value. You will keep the 5 constant and decrease this value. So what you will do? You will increase this value. You will increase 5 by 3, or you can write it 5 by 4, or you can write it 5 by 5. Okay, so here you will get 1. Here you will get 1.25. Okay, here you will get 6.6. Here you will get 1 point something. Okay, so we're saying here that if you increase this value, the denominator, the whole value will decrease. For example, 10 divided by 2, 10 divided by 5, 10 divided by 10. If you keep this 10 constant, you will find that this value, on increasing this value, the overall value will increase. Sorry, decrease. So if you keep this value 2, then it will be the 5 as an answer. If you increase this value to 5, it will be 2 as an answer. Here, if you keep this value 10, it will be 1 as an answer. So how can you increase the density? So decrease the density. I am saying the density of ice decreases, or we can say the density of liquid decreases or water decreases when it change into ice. Okay, I'm saying that the liquid when changes into solid, its density decreases. It has lower density. Okay, and it has high density. So if I'm saying that if you are having a particular amount of water, okay, particular amount of water, and you are just converting into ice, then it expand. The volume will increase. This value will increase. So mass will remain constant and volume of the water increases. Because this value increases, just I have shown you that this if this value is kept constant, and if you are increasing 2, then 2 to 5, then 10, if you keep this denominator increasing, you will get overall density as less. So in simple, we will say that when when liquid changes into solid, in case of especially water, the volume increases. And since the volume increases, the density decreases because the mass will remain same. The mass is not going to increase. We are not removing the water from it. Mass will remain same. But when the volume increase, the density will decrease. When you increase this value is automatically decreased. On increasing this value, the density will decrease. The overall this value will decrease. As a result of which, due to density decreases, this ice is able to float. So let me show you that how it is floating. Let me show you. Let me show you, just wait. You have seen this one also. If you kept the tightly packed bottle, just plastic bottles, and you kept it in the refrigerator for freezing, the bottle will burst. Okay, bottle will burst. Even the okay. So let me show you. Just I'm showing you. So you can check here, dear students, that this bottle, we are just keeping this bottle, okay, and we are just filling it with water. This is the bottle. This is filled with up to brim, okay, and just you can check. They both are kept, okay. And when you keep this one in the refrigerator, you will find that due to expansion, you can check it. This bottle get cracked. This bottle get cracked. Why? Because water's volume increases on freezing. And since the volume increases, density decreases. So water is expanding because it is having air gaps. Okay. So it is expanding. It needs more space. And due to that, it expands. Okay. And due to expansion, you can check this water is also freezing here. And this also get. So you can check it. This he filled the water up to brim, but this water comes out. Okay. And here these bottles get get bursted. Why these bottles are getting burst? Because ice, when water freezes, then its volume increases, and due to increase in volume, the density decreases. And why the volume increases? Because when ice, or sorry, in ice, the water have some structure in which the air is trapped, and due to that it expands and the density decreases. That's why it floats. Okay, so we're going to write these answers in the next class. Okay, we'll start from this one, but you need to keep in mind that when water is converting into ice, that its density decreases. The reason behind this is simple: because volume increases, mass will remain constant. How can you decrease that density? You have to increase the volume. So for increasing the volume, the density will automatically decrease. So this is the reason. Okay, and we'll write the answer.